Hello everyone, my name is Michihiro Kandori. I'm a professor at University of Tokyo. I do research in game theory and economics. Welcome to game theory. Well, game theory is a very fancy or sexy name which naturally attracts lots of people's attention. And game theory has been applied to a number of fields in social sciences, humanities, and natural sciences, engineering. So lots of you might have heard about game theory. Well, this is an introductory course on game theory, and I'm going to emphasize basic concepts like what rationality is and what does it mean that people play equilibrium strategies, okay? And I try to explain ideas and philosophy and a little bit of history. So I focus on conceptual aspects of game theory, and I use very little math. Maybe occasionally I solve few equations and I do some symbol manipulations. But rather than presenting, advanced mathematical models and telling you how to solve those mathematical models, I just explain ideas and philosophy hidden behind mathematical definitions. So if you are interested in how to solve mathematical models and what kind of mathematical models are presented by game theory, you can take other courses in Coursera offered by Matt Jackson and others. Okay, so let's begin the first lecture. What is game theory? Okay. So let me give you an example of the subject of game theory. Political campaign between the Democrats and the Republicans. This is an example of the research subject of game theory. Okay? And negotiation in business and politics or even daily life. And competition in markets, traffic on the roads, and struggle for existence of animals and plants. Those problems are similar to, say, a card game where individuals try to do their best against others. So game theory concerns social problems. In a social problem, you are not the only person who makes a decision. You interact with others. And you need to think about what is best for you. And since you are interacting with others, usually, what is best for you depends on what others do, okay? Such a situation is called a strategic situation. Okay, so let's go back to the example. The political campaign between Democrats and Republicans, what is best for the Democrats depends on what Republican is going to do. In negotiation, what you are going to do, what you should do depends on how opponent is going to react, and so on. Okay, so the game theory constructs mathematical models to examine or to predict how people behave in such a strategic situation. Okay, so this is the subject of game theory. Okay, now I must give you an important remark. I have to tell you what game theory is not about. Okay, so game theory examines people's behavior in strategic situations. Therefore, game theory is not about your favorite video game. So if you are interested in video games and came to this course, well, this is not for you. Okay, so let me give you a few examples about what game theory tells you. Okay, after learning game theory, you can solve the following interesting questions. Okay, question number one is about the political campaigns between the Democrats and the Republicans. Okay, the question is here. What determines the policies of the two parties, Republicans and the Democrats? Well, this is a very general and vague question. Think about how you can approach this question. It's not so obvious where you start. But game theory provides you a unified way of solving all social problems, including this one. So you formalize political struggle between the two parties by means of a simple mathematical model. I'm going to show you how to do that. And then you apply the basic solution concept of game theory, and then you get an answer. Okay, this is what I'm going to tell you at the end of this week. Question number 2 is about the traffic on the road. Okay, so let's see this map. There are two cities here and there, say city X and city Y, and those are the existing roads. And the question is, what happens if we construct a new road coming from X to Y? How does it affect the traffic on the existing road? And how you can save traveling time from X to Y? Okay? This is a very important policy question. Again, this is a strategic situation. Okay? If all the drivers jump to the new bypass, then this bypass is too crowded. And maybe you'd like to use the existing road. So what is best for you crucially depends on what other drivers do. This is a perfect example of game theoretic or strategic situation. Again, you formulate this social problem as a mathematical model of game, and then you apply the basic solution concept, and then you get the answer. Well, I'm going to tell you the answer by the end of this week. Okay, so game theory has been applied to a number of research fields, okay, including economics. This is the first place where game theory was born because in all social sciences, economics was the first to use mathematical approach. But now, game theory has been applied to other, fields of research in social sciences and humanity, like psychology, political science, and sociology. Outside of social sciences and humanity, game theory has also been applied to natural science, notably biology, and also computer science. Okay? So the struggle for existence of animals and plants, it's a kind of game. What is best for one species may depend on what other species behave. So you can apply the concept of game theory to biology. And the branch of biology which uses game theory is called evolutionary game theory. Okay, what about the relationship between game theory and computer science? Computer science used to analyze the calculation performed in a single computer. But now, computers all over the world are interconnected with network. Okay? So those computers are collaborating or often competing to perform their calculation. Okay? This is also a strategic situation, and game theory can be fruitfully applied to computer science. Well, I am an economist, and I do research in economic theory, but I have been collaborating with sociologists and computer scientists, and I have been interacting with biologists. Game theory provides a common language which facilitates interdisciplinary research in all those different fields.